In this video, we will learn about this topic. Before we get into today's video, if you love our videos, be sure to click like button below. And make sure to click subscribe and the bell to receive notifications of new simplified videos.
When operating industrial machinery, safety is always a primary concern. Two-hand controls and anti-tie-down circuits are safety devices built into the design of electrical circuits that operate industrial machines. Two-hand controls are an actuation device that requires the concurrent use of both hands of the operator to start a cycle. The purpose is to prevent the operator from having any part of his or her body in the work envelope of the machine during its operating cycle. Two-hand controls can also describe a machine that requires two separate operators typically located on opposite sides of the machine. Both operators must be in place to allow the machine to start its cycle. For this type of machine, two-hand operation controls typically consist of two push buttons wired in series. This type of two-hand control is simple to install and is fairly safe if two operators are present with physically separate control panels. If only one button is depressed, the electrical connection is not made and the machine will not start. As shown in the circuit, only the actuation of both push buttons allow the solenoid to energize. The solenoid then shifts the valve to allow air into the cylinder, which produces the machine's stamping motion. While two-hand controls wired in series is ideal for machines with two operators, it becomes unsafe when only one operator is present. Although two buttons are still required, it becomes much easier for a single operator to tie or weigh down one button, allowing unsafe operation. To prevent this unsafe condition but still permit a single operator, anti-tie-down circuits are employed. An anti-tie-down circuit requires that the operator actuate both individual controls at the same time. If either control is prematurely actuated or continuously tied down, the cycle will not operate. In this circuit, a double solenoid three-position valve is connected to a cylinder which actuates a limit switch. The valve's solenoids are operated by two buttons, each one having a normally open and normally closed set of contacts. They are wired with both their normally open and normally closed contacts in series. Both buttons must be pressed to energize valve solenoid A and start the cylinder forward. When the cylinder begins to move forward, limit switch 1 is released and goes to its normally closed position. If either button is released, both solenoids de-energize and the springs return the valve to its neutral center position, stopping the movement of the cylinder. If both buttons are released while the cylinder rod is extended, limit switch 1 allows solenoid B to become energized. The valve will shift to allow fluid into the rod end of the cylinder, causing it to retract. When it reaches the end of its stroke, it engages the limit switch, which opens the circuit and prevents electricity from flowing until the two start buttons are engaged once again. If both buttons aren't released, the cylinder cannot move back to its starting point to restart the cycle. Another way to prevent tie-down is to utilize a double solenoid two-position valve. The valve is much simpler and less expensive, but requires a more complex circuit utilizing an off-delay timing relay, normally open-timed open-timer contact, a control relay, two solenoids, and a normally closed limit switch. When both push buttons are in the unactuated position, the timing relay is energized and the normally open-timed open-timer contact is shut. No power can flow to the control relay. If an operator depresses a single push button, power to the timing relay is removed and the off delay timer starts to time. Only when an operator depresses both buttons within the off-delay timer countdown period can power flow to the 1CR contact relay and energize the bypass circuit. The timing relay will remain closed until its countdown completes, usually just a fraction of a second. After the allotted time, the normally open-timed open timer contact swings open. With the control relay energized, power 2 flows to solenoid A. Solenoid A shifts the valve to allow fluid into the blind end of the cylinder. The cylinder begins to extend the cam and releases limit switch 1, allowing it to close. At this point in the cycle, the cylinder will remain extended indefinitely until at least one push button is released. If one push button is released, the control relay will lose power, which causes 1CR to remove power from solenoid A and connect power to solenoid B. This shifts the valve, allowing the rod end of the cylinder to fill with fluid and retract the cam. When the cylinder is fully retracted, the cam energizes and opens limit switch 1, which removes power from solenoid B. The cycle cannot begin again until both push buttons are released. When the second push button is released, the timing relay is energized and the timing switch reset. The cycle is now ready to begin again when both push buttons are engaged. In some manufacturing industries, such as those that produce castings from foundries, two-hand controls are mandated on specific equipment. It is the system design team's responsibility to select adequate means of operator protection. Two-hand controlled machinery is an easy and effective way to ensure safe operation of industrial equipment.